Sharks have been an elusive and mysterious group of animals for centuries. There have been many theories, myths, and tales about these predatory fish, but it is only in recent years that scientists and researchers have made headway with establishing concrete facts about such animals. Shark tracking has already shown us new things that we didn't know about before. Previous research suggested that white sharks prefer open water and rarely venture into kelp forests. But new research using the Monterey Bay Aquarium Research Institute inspired camera tag shows us that some sharks in South Africa spend a lot of time in kelp beds, where they may even be hunting for seals. Observations of white shark foraging behavior show they generally surprise their prey and swim up from below to attack animals like seals and sea lions at the ocean surface. The study published recently, however, suggests that white sharks may exhibit a different hunting strategy in a habitat that was once considered off-limits for these large predators, the kelp forest. These discoveries show us how innovative technology developed at Monterey Bay Aquarium Research Institute can help scientists around the world gain a new perspective on the ocean and its inhabitants. Researchers in South Africa used a video tagging technology called Animal-Born Video, an environmental data collection system, which has featured inspired by Monterey Bay Aquarium Research Institute's Shark Cafe Cam. Using this system, they made surprising discoveries about white shark behavior. Since 2015, engineers at Monterey Bay Aquarium Research Institute and researchers at the Monterey Bay Aquarium have been working together to develop an open-source video camera tag that would allow researchers to observe the behavior of these sharks directly in their natural marine environment. The new camera tag would need to stay on for several months. It has to be small and easy to attach to the shark's dorsal fin. It has to stay on the shark for up to 9 months until the shark returns to the California coast from its offshore location. It has to survive deep dives as deep as 1,000 meters and bursts of acceleration to speeds up to 25 miles an hour. It needed a battery that could power 10 hours of video recording, as well as internal data processing and storage system, and it has to be programmable. Sharks are tracked either via satellite or by a process called tagging. Both of these methods are somewhat traumatic for the animal as it needs to be caught and immobilized for a brief period of time. Captors need to ensure that their method of catching and tagging the shark is non-invasive and has as little of a negative impact as possible. While tags mounted to fins may cause fin irritation, drag, or even result in fin damage, there is no evidence to date suggesting that it would impact the survival of the shark. The shark can be followed for the life of the tag battery. The OSearch website has tons of sharks that are being tracked. It shows many different species of sharks, like white sharks, tiger sharks, and blue sharks and whale sharks. It shows us where they travel, their behaviors, how far they will migrate, their age, when they started tracking, and their latest location. This shark tracking data can actually help with shark conservation. They can reveal key areas to prioritize for protection, such as mating, feeding, or nursery grounds. They can determine sites where sharks are most likely to interact with fishing activities. They evaluate whether marine protected areas are sufficiently sized or placed to adequately protect sharks. And they also predict the impact of climate change on the shark's movement and distributions. Scientists and engineers are constantly working together to improve tag performance, power, data acquisition, sensor capabilities, data acquisition attachment techniques, as well as reduce tag size, drag, and improve animal welfare.